Hi everyone, this video is on exercise 12 of question 2. So we want to find the equation of the normal to the curve with the equation y is equal to x squared minus 8 over root x. Okay, so if we want to find the equation of a normal to a curve, we basically need to use the same approach as finding the equation of a tangent to a curve. So remember that the normal is a line that is perpendicular to the tangent. So that means if we manage to find the gradient of the tangent, then we can find the gradient of the normal. And obviously we are given the point. So remember that if you want to find the equation of any line, we need to have the gradient of the line as well as a point on the line. So we are given the point, we just need to find the gradient. And the way that we can find the gradient of the normal is by finding the gradient of the tangent to the curve. So let's first find the gradient of the tangent. Maybe a picture can help. So let's say if this is the curve, just random curve for example, and let's say this is point P. So this is the tangent to point P, and this is going to be the normal to point P. So the idea is that we can find the gradient of the tangent line, and that obviously can help us to find the gradient of the normal, which I'm going to show you how we can use that to find the gradient of the normal. Okay, first we need to differentiate this function in order to find the equation, the gradient of the tangent. But let's rewrite the function in the form x to the power of n. So it becomes x squared minus x times x to the power of minus a half. So that's the first step. Then we can differentiate. So divide by dx is equal to 2x. Then minus a half times minus 8 is just plus 4x. And then minus a half minus 1 is minus 3 over 2. Okay, now that we have the gradient, we can then, the equation of the derivative, we can find the gradient of the tangent. We just need to substitute the x coordinate of the point into this equation. So when x is equal to 4, divided by dx is equal to the following. So 2 times 4 plus 4 over, because x to the power of minus 3 over 2 is equal to the square root of x cubed. And in this case, remember that the value of x is 4. So instead of x4, we just substitute and write 4 cubed. Okay, now that we have this, then we can just solve that. So divide by dx is equal to 2 times 4 is 8 plus 4 over. So 4 cubed is 64, and the square root of 64 is 8. And the gradient is equal to 8 plus a half. And that's equal to 17 over 2. So this is the gradient of the tangent at point P. But remember that we want to find the gradient of the normal because we want to find the equation of the normal. So this is a fact that we should always remember, that the gradient, if m is the gradient of the tangent, then the gradient of the normal is a negative reciprocal of the gradient of the tangent. So the gradient of the normal will be minus 1 over m. So that means whenever you find the equation of the tangent, the gradient of the tangent, then the gradient of the normal is the negative reciprocal of that. So in this case, the negative reciprocal of 17 over 2 is minus 2 over 17. So we say gradient of the normal is minus 2 over 17. Okay, now we have the gradient of the normal. We have the point. So the point is 412. Then we can just use the equation y minus y0 is equal to m times x minus x0 and substitute everything to find the equation of the normal. So y0 is the y coordinate of the point. The y coordinate of the point is 12. The gradient is minus 2 over 17. And then the x coordinate is just 4. Okay, and since the question hasn't asked for a specific form for the final answer, we can basically leave our answer in this form. So we can just maybe just add 12 to both sides to make it look nicer. So we are going to have minus 2 over 17 times x minus 4 plus 12. And yeah, I'm going to stop here because there is not a specific form that we want to write here. So this is basically the equation of the normal. All right, that's it for this video, and thank you for watching.